Okay, hey guys, let's find this integral. So it goes from 0 to 1 and then 1 over x dx. So this is kind of like a beginner's video on improper integrals. I'm going to draw some pictures to help you understand what's going on. It does help, first of all, if you have a clear picture of what 1 over x looks like in a graph, because that makes the limits of 1 clearer, and it certainly makes the meaning of the 0 on the bottom clearer. So let's begin with that. So I'm going to make a picture that looks like the following here. Okay, and let me draw the graph in here. So roughly in quadrant 1 it looks like this. This is the graph of 1 over x, and this is the x-axis. Now something happens here with 1 over x, which is that here there's always a gap that never ever goes away. Now look at our integral. It looks like 0 to 1 of 1 over x dx. So now look at it. There's a 0 on the bottom and there's a 1 as the upper limit. We have to connect that information to the picture so you understand what's going on better. So how do we do that? This upper limit of 1 here, let's say we mark that like here. This is our 1. This is the upper limit right here. It's a value of x. But then we also have this lower limit here of 0. So let me erase this. So this is x equals 0. Now, what happens here? Well, look, first of all, going back to this, if you try to do 1 over 0, then you have what? D N E. It doesn't exist, correct? Remember, this was an arrow. Let me delete this. Okay. That doesn't exist, which means like x equals 0 itself is not part of the domain of 1 over x. Okay? So, that's important because that means over here we're going to do the following. We got to get 2x somehow here, but we got to do it by what? Approaching it from the right side. This is x is approaching 0 from the right side, right here. You see that? Because 0 itself cannot be plugged in, we got to approach it from the right side. In other words, as soon as you hear the word approach, you got to think about what? Limits, correct? You got to think about limits. Okay, so now let's continue. Let's actually evaluate this thing. So I would say the limit, I'm writing that because of this. And now go back to the here. Notice that here we have x, correct? You don't want to use x as like one of the upper or lower limits of integration because there's already the x in the integrand. It's going to get confusing. What I mean is this, right? If you wrote it this way, like 1x and then 1 over x dx, then you would have the lower limit is x. There's an x in here. To avoid that misunderstandings, we'll do this instead. I would say the limit as t approaches 0 from the right side. So this part under the limit is just the translated version of this thing here. I'm just using t instead of the x, that's all. So limit as t goes to 0 from the right side of the integral here that goes now t on the bottom, not 0 anymore, up to 1 and then 1 over x dx. So again, let me emphasize, by doing this, it's pretty clear that here we have t and we have x. We have different letters. Okay. So we can evaluate this from here as follows. Let me delete this part here. So it's the limit as t goes to 0 from the right side. And this is easily anti-differentiated to give us ln of the absolute value of x, evaluated between 1 and t. Okay. What happens from there? You're going to have the limit as t goes to 0 from the right side. And this is going to be ln of the absolute value of 1, plugging in, minus the limit. So the limit has to officially be applied to both, as t goes to 0 from the right side of ln of the absolute value of t. So this part especially, like the fact that the antiderivative is like ln of x, you got to know that from the lower level classes, okay? Okay, what happens here now? So now we have to go back to like pre-calculus, for example. Let's focus on this part, ln of 1, okay? So let me remind you, the ln function looks like this, roughly speaking. And this is 1. So when, like, this is a value of 1, ln of 1 is equal to 0. That means this entire expression right here is equal to what? It equals 0. Because you can evaluate ln of 1 directly from its graph, for example. So you're going to end up with a separate picture here. Okay, you're going to end up with 0 minus, and now what happens with the next part? Okay, let's evaluate this and analyze it carefully. So first of all, we should observe something important here, right? Look at this. This is t is going to 0 from the right side. Okay? So that means, imagine this is the t-axis, because the t is now our variable here, so it's the t-axis. And because t is going to 0 from the right side, so if this is 0, then we're approaching from this direction, correct? But that means that ln of the absolute value of t is just ln of t, that's it. You don't need the absolute value bars, because here all the t's are already positive. You can just write ln of t to simplify. Alright, and then on top of it, ln of t looks like this, correct? Like this. So that's just, again, using the basics of the ln function. Instead of having x as our variable, you have like t as our variable, for example. So that's important to understand, because that means now we can write the limit as t approaches 0 from the right side of ln. We can just write this, ln of t with like parentheses and not absolute value bars. What happens? What's the value of this limit? Well, again, this is now approaching 0 from the right side, this arrow here. You see that the y-coordinates slide down towards negative infinity. So you're going to have 0 minus, and again, this whole thing, to emphasize, this whole thing pretty much, that's just equal to negative infinity without the negative here. Okay, so it's going to be 0 minus negative infinity, which is just what? Infinity. What does that mean for us then about the original question? Well, it means the following to answer it. That the integral, that's just an insult to the integral symbol. Let me do that again. So the integral from 0 to 1 of 1 over x dx, we in other words say something like this. It diverges, okay? And that's expressing itself, for example, in limits where you get an infinity, or maybe a negative infinity, depending on the specifics. Okay, so I hope this has been helpful to you. I've explained it as carefully as I know how to explain. Please be sure to leave a like and subscribe and share to help perhaps other people. I'll see you in another video.